Episode of the SAP on AWS Virtual Workshop series. We really appreciate everyone taking time out of their busy schedules to attend this session. Today, more than 5,000 active customers already run SAP on AWS. And as more and more SAP customers look to make the transition from on prem or other cloud providers to AWS, many are looking for guidance on how to migrate efficiently and take advantage of AWS's industry leading best practices. Hence, this three-part series on securing, deploying, and migrating SAP systems on AWS. My name is Bidwan Barua, and I'm a SAP Specialist Solution Architect with AWS. I am part of the worldwide sales organization team, and in my current role, I help customers architect, migrate, and run their SAP workloads on AWS. In the first episode yesterday, you learned how to implement AWS's security best practices like creating a hardened AMI along with other security related configurations. In this episode today, you'll learn how to deploy SAP S for HANA on AWS. And in the next episode tomorrow, you shall gain insights on how to migrate and optimize S for HANA on AWS. So to deploy a SAP S/4HANA system on AWS, first you shall have to decide on the architecture pattern. In this episode today, I shall talk about the different architecture patterns for SAP on AWS. Based on these architecture patterns, we shall see how to deploy a SAP system on AWS using AWS Launch Wizard. And we shall conclude by looking at how to back up this newly deployed SAP system using AWS Backend Agent. We shall open the floor for Q&A at the end. If you have any questions in the interim, you can put it via the chat application, and one of my colleagues will be happy to answer those. So let's jump right into the first topic, architecting a S/4HANA system landscape on AWS. The primary principle while architecting a SAP system is to consider reliability, security, performance optimization, and cost optimization, and operational excellence, which are also the 5 pillars of AWS's well-architected framework. Now, for mission-critical SAP systems, reliability is of utmost importance. I'm sure you would agree that if a SAP system is down for a minute, there is chaos everywhere. Reliability is closely tied with availability and fault tolerance, which we are going to discuss next. Famously, our CTO Werner Vogels once said, everything fails all the time. So we need to protect our SAP systems from failure. It could be physical, it could be logical, or any other different types of failure and disaster. Before I dive deep into the HA and DR aspect, I think it is very important to understand that the terms HA and DR take very different meanings in the context of on-prem versus cloud. The terms HA and DR have historical meanings. Cloud services, and AWS in particular, has revolutionized the meanings. Usually, from most perspectives, on-prem HADR is not equivalent to cloud availability. Let me explain why. Historically, on-prem HA meant protection against a hardware failure within the same data center. But within AWS, we have things like auto recovery inherently, wherein if underlying hardware or software or network has those kind of issues, it would be moved to another host within a few more minutes. You don't need to set up HA in AWS for those kind of events. And similarly, traditionally, DR means moving over to another data center in another geographic location in case of a disaster on the primary site. Essentially, it focuses on protection against one data center or one geographic location. Our availability zones have these protections inherently. If you set up your SAP systems across availability zones, you have geographic protection or protection against a single data center. So what are availability zones? Availability zones, or AZs as they are popularly known as, are a cluster of data centers, each with redundant power, networking, and connectivity, hosted in separate facilities in different floodplains. Moreover, our native AWS services are architected in multi-AZ mode by default. So what does all of this information mean? It means that we need to think broadly. What are we trying to protect our SAP systems from? Is it physical error? Is it logical error? Is it a disaster? What is the agreed upon RPO and RTO with the business around which we need to architect our systems around? Most importantly, is it cost effective? For example, does it make sense to run a hot standby database if we can tolerate outages of, let's say, a couple of hours? So we have many customers who have set up systems with the single reason across multiple AZs because they view this as both HA and DR because of the separate physical locations, separate physical power grids, and also they have several data centers protecting their data. Similarly, we have customers who say that they have compliance requirements to set up their DR, let's say 200 miles away, or they want to protect themselves against disruption to an entire AWS region. In that kind of a scenario, they use a separate AWS region as a DR site. For sake of simplicity, for rest of the presentation today, when we talk about DR, we shall consider utilizing a separate region as the DR site. So now let's see the different architecture patterns for SAP on AWS. So based on the type of events you decide to protect your SAP systems from, you will end up selecting one of these three architecture patterns. Single AZ is primarily used for non-prod environments wherein you don't need high availability configured. So you deploy all the components of your SAP system in a single AZ. Multi-AZ is the recommended pattern for production workloads, wherein we advise to set up HA by taking advantage of two of our numerous AZs. Herein, you will deploy SAP's components across two different AZs for high availability. Multi-region is usually applicable for a DR setup, wherein you have your most important components available in a certain separate AWS region in case of a disaster. We shall discuss each pattern in depth in a few minutes. So first, single AZ, single instance architecture. Now, within the single AZ architecture pattern itself, you have different ways you can deploy your different components of your SAP system. Herein, all the components of an SAP system are deployed on a single EC2 instance. We don't recommend single instance architecture as a general best practice for your higher environments like QA or prod. It's okay to use this pattern for a sandbox or for a POC system or even for a development system if cost optimization is an important factor for you. The reason we don't recommend this deployment pattern is to make sure that you always follow the cardinal rule of cloud deployments. Reduce the blast radius. Now, what is a blast radius? You can think of blast radius as the maximum impact that can be sustained in the case of a system failure. To build reliable systems, you want to minimize the blast radius. For example, let's say if your primary application server or your additional application server is impacted by an underlying issue, you don't want your entire system to come down. But with single instance architecture, your entire system will be impacted. So, which means that if you separate out the SAP components like central services, the database, the lesser the blast radius becomes, the better for you. Now, when I talk about separating the components out, I'm referring to the distributed instance architecture pattern. As you can see, components are separated out. If in this pattern you have another advantage, you can save some cost by shutting down a certain number of application servers when they are not required. Let's say you have a training system which are used for training your employees on SAP. It can be like functional training or a technical training, depending on how you set up your training curriculum. Additional app servers can be shut down unless a huge group of trainees show up. Similarly, same logic goes for QA testing. If you are not doing a full-blown QA testing, you can shut down certain application servers. And You can also use this pattern for production system if you decide that, okay, I'm not going to use high availability, I'm not going to use multi-AZ architecture, then you are okay. And you are okay with high RPO and RTO for resuming your operations in case of a disruption. If you need near zero RPO and RTO for disruption to any SAP component, you would need to use the multi-AZ HA deployment pattern that I'm showing here in this slide. For your production systems, we strongly recommend multi-AZ HA architecture. Here you have your ASCS running in one AZ, ERS running in another AZ, and the application servers are also divided between the two AZs. You have your primary database running on AZ1, and then you have a secondary database on AZ2. You have some kind of a database log replication setup. In case of HANA, it's HSR. And then this entire HA architecture works with the concept of what we call within AWS as overlay IP. So what is an overlay IP? Overlay IP is nothing but think of it as a virtual IP. So the overlay IP will point to the active ASCS instance at the time. So in case this instance goes down or there's some kind of issue and the failover happens to the other instance where ERS is running, then the overlay IP will be moved. This is usually taken care by third-party clustering software like from SUSE, Red Hat, so on and so forth, right? So and all this is orchestrated by the route table. So what is a route table? So route table is a set of rules called routes that are used to determine how to direct the network traffic. So we'll get into the details a little later. So far, and then also there are customers who say we don't want to use clustering software. So AWS is all about the customer's choice. So if they want to do the takeover, the failover process manually, there are customers doing it, but we always suggest to use clustering software from SUSE and Red Hat or other third-party clustering software providers. So now I spoke about the different architecture patterns from a HA perspective, right? Single AZ, within single AZ, how you can deploy in single instance, distributed instance. And then I spoke about a little bit about multi-AZ, which we'll go in detail a little later on. Now I'm coming to disaster recovery strategies. While there are a number of DR architecture patterns, you can mix match between the different patterns that I'm going to talk about today. But primarily, there are three different patterns that we recommend our customers. First one is passive DR. In passive DR, no infrastructure is provisioned in the DR site, relies totally on backups, hence the name passive DR. Then we have pilot-light DR, infrastructure of only the most important components of an SAP system like the database is provisioned, that to downscale, hence the name pilot-light DR. And then we have warm standby DR, wherein the complete infrastructure of the critical systems, of the critical components of an SAP system like the database is provisioned exactly like the primary side. So in case there's a disruption to the primary region, you are ready to run your operations immediately with the lowest RPO and RTO. Let's deep dive, right? So from an SAP perspective, we have two layers to take care of to make sure that the SAP system runs properly. The first is the application layer, and then you have the database layer. In the passive DR mode and the pilot-light DR mode, the application layer is taken care by the Amazon Machine Images or AMIs. Think of AMIs as a image of a VM in simple terms. And in the warm standby database, the application servers are replicated real time using our storage-based replication tool called Cloud Endure. And in the database layer, in the passive DR mode, it is taken care by backup. So we don't provision any instance to run any database node on the secondary DR side. So the database backups are taken, replicated to the DR region, and in case of a disaster, we use different tools to bring the system back up from the backups. And in the pilot light DR, we, for example, we use different technologies depending on the type of the database. For example, for HANA, we don't use the preload. The loading of the column store tables. So that's how we can reduce the size of the instance, and the database replication is kept on. So the database replication is kept on, and so the latest data is available in the secondary DR region. And in case of a DR, we just change the instance type to the required instance type, and then you are ready to go from a DR perspective. And in a warm standby DR mode, both the instances are like to like. For example, if you're running a R5 large on the primary side, you are running the same instance on the DR side, so you don't have to change the instance type in case of a disaster. This gives you the lowest possible RTO. Now, let's deep dive into each one of these options. Before I go to the DR side of things, let me explain the architecture at the primary side in this architecture pattern. Here is the highly available SAP system architected across two AZs. Now we need to take care of the application servers and the database. For the application servers, you provision the app servers, spinning up from the AMIs in case of a disaster. So you create the AMIs, you copy them over to the DR region, and then in case of a disaster, use the AMIs to spin up your application servers. For the database, you have two options. In case of a disaster, install HANA manually, or use our AWS Launch Wizard, which I'm going to focus today, to provision the infrastructure and install the database. Right? In the pilot light DR, we have a small instance provisioned in the secondary instance, in the secondary DR side, to which the primary database is replicating using asynchronous mode of replication. It is changed to a full-scale production instance in case of a failure event. So some things to keep in mind is capacity reservation. So in case of a disaster in the primary region, there would be multiple customers who would be needing instances on the DR side, right? So you need to keep capacity reservation in mind while planning for a pilot light DR, as well as passive DR. In case of a warm standby, in case of warm standby DR architecture pattern, you don't have to worry about capacity reservation, because you already have a exact size instance provision for you in case of a disaster. So the instances are similar to what you have in your primary region, and you use this architecture pattern to make sure that you don't have to worry about capacity reservation. You don't have to worry about higher RTO in case of a disaster. The Cloud Endure tool will spin up the application servers for you, ready to go, and then you have your database. So all you need to do is kind of making sure the application is able to talk to the database, and with this pattern you achieve the lowest RPO and RTO possible, right? So this is the warm standby DR pattern. So to recap, so far I spoke about the different architecture patterns: single AZ, multi-AZ, and within each pattern we saw the different variants like single instance, distributed instance, high availability, as well as different options available for DR under multi-region architecture. Now you have the information to select the right architecture pattern for your use case. Let's see what EC2 instance type you need to select for your SAP systems. Remember, not all EC2 instances are certified to use for your SAP production systems. Only instances certified by SAP as per note 1656099 should be used. Always refer to this note to make sure that you have the latest information available for EC2 instance types. We shall discuss more about this in this section of the presentation. Amazon EC2 offers a number of instance types for deploying SAP solution. Think of EC2 instance as a VM. Each instance type is optimized for different use cases with various combinations of CPU, memory, storage, and networking capacity. This gives you the flexibility to choose the appropriate mix for your application. Each instance type includes one or more instance sizes like small, medium, large, extra large, twice extra large, so on and so forth. This allows you to scale your resources to the requirements of your target workload. Gone are the days when in on-prem you had to size your SAP systems for a 3-year or a 5-year perspective. You have to consider growth when you are sizing your SAP systems. With AWS, you right size for today. And then if you need a larger size instance 1 year from now, 3 years from now, you change the instance type. For example, from 2x large to 4x large. In fact, with all greenfield implementations, we recommend to follow this approach. With growth, change your instance type. Um, Same goes for other types of implementations. You can run non-production SAP systems on any other, Amazon EC2 instance type, but you need to use the SAP certified EC2 instance type for production SAP systems. SAP certified EC2 instance types have a SAP's performance rating, which is tied to your sizing exercise, which can help you guide in deciding which instance type you need to select and which instance type fits the requirements of your SAP system. So let's start from our left of the slide, right? First instance type that I'm going to talk about is the general purpose instances. General purpose instances provide a balance of compute, memory, and networking resources and can be used for a variety of workloads. The first one that you might notice is our newest 6th generation instance, M6i, which offer up to 15% improvement in price per performance versus comparable 5th generation instances. Typical use case for general purpose instances for running SAP are SAP application servers. So for running SAP application servers, you can either select M5 or M6i instances, depending on your preference. You might have noticed that with our 6th generation instance, we have a suffix I. This stands for Intel processor. We are already using suffix A for AMD and G for Graviton. So this is a new naming convention we are starting. So that's why you don't see M5i. This is something new with the 6th generation. And then coming to the middle section, compute optimize. Compute optimized instances are ideal for compute bound application that benefits from high performance processors. Apart from C5, we have C5N. The N signifies that it is network optimized, which provides a higher network bandwidth. Then also we have C5A. Like I said earlier, A stands for AMD. This comes into play when you'd like to lower your cost. So between C5 and C5A, the cost of the C5A is a little lower. So that's a choice we have given to our customers. And in general, you will be using compute optimized instances for a SAP application like SLT, which needs a lot of compute resources. And then finally, we have our memory optimized instances. Memory optimized instances are designed to deliver fast performance for workloads that process large data sets. Think of it as database applications. It can be Oracle, HANA, so on and so forth, right? So the R5B instances are memory optimized instances that increase EBS storage performance by 3 times compared to the R5 instance. So that's the difference between R5 and R5B. And then we have the U-type instances, which are our high memory instances. These instances are purpose-built to run large in-memory databases. including production deployments of SAP HANA in memory. So the U-type instances for most cases are available in two different flavors. The virtual instances, which got released recently, and then also we have our bare metal U-type instances. The cost of both bare metal and high memory virtual instances are same for 6 terabytes, 9 terabytes, 12 terabytes when it comes to 1 year or 3 year reservation, including using reserved instances. Virtual instances offer additional purchase option like on demand. So if you want to use a 6 terabyte instance and you want to shut it down when you're not running your operations, it can be a sandbox, it can be a development system, even a development system. In that case, you can go with our virtual memory virtual instances of 6 terabytes. The latest instances are all powered by Intel Xeon scalable processors, which are also codenamed Ice Lake, right? So these are the Amazon EC2 instances that you can use to run your SAP applications. And then we have a separate list for HANA, because for HANA, you need a separate SAP certification. This is published by SAP and is available in the certified and supported SAP HANA hardware directory published by SAP. So always go to the SAP website to get the latest information. Here's the list of EC2 instances which are certified to run HANA for your easy consumption. So they say a picture paints 1,000 words, right? So, well, in our case, this slide summarizes all the current scale up and scale out options that you have with SAP HANA on AWS. Scale up OLTP workloads like SAP Business Suite, ECC on HANA, SAP S for HANA are supported on a single node scale up configuration up to 24 terabytes of memory. Scale out OLAP workloads like data marts, analytics, BW for HANA, SAP BW, SAP BPC on a multi-node scale out configurations are available up to 100 terabytes of memory. For SAP S for HANA specifically on a scale out deployment, it is supported up to 48 terabytes. Now, moving ahead, the next 3 slides, I'm not going to talk in detail because this is just a list of all the instances which are certified for SAP workloads. Always refer to the note that I spoke earlier, 1656099, for more information and for the latest information. I thought I would include this slide, for your easy consumption and for a quick reference guide. Now let's come to the main topic for today. By this time, you have a fair idea about the architecture pattern, what architecture pattern you need to select. You have a fair idea about what instance type you need to select for your SAP systems. Like for running HANA database, you'll be selecting memory optimized instances like R5s, right? Or or our U-type instances. For application servers, you would be selecting general purpose. These are like general rules. Everything depends on your sizing exercise, your SAP's requirement, so on and so forth, right? So now you have a fair idea about the architecture pattern, about the instance types to select. Now the next point is how to deploy S/4HANA on AWS. So we have our tool called AWS Launch Wizard, which I'm going to discuss next. So we started the journey for automated SAP system deployments back in 2014 when we introduced AWS Quick Start for SAP HANA. This was the first automation tool to install SAP HANA database together with provisioning the EC2 instance and the EBS volumes. AWS Quick Start includes AWS CloudFormation templates that automate the deployment of AWS services and infrastructure as per the infrastructure as a code standards. In April of 2020, we announced AWS Launch Wizard for SAP, which moved the automation to a completely new level with our new user experience, new tool, and it is designed for new SAP workloads deployment on AWS, as well as to migrate existing on-prem SAP workloads to AWS. That's what we are going to see today. It provides many features, the Launch Wizard, and as you can see, with time we are making innovations every month, every other month. New features are released from a Launch Wizard perspective. Give me 1 second. Yep. Uh, some of the features, some of the great features for people who are not very familiar with SAP, right? Organizations who are doing greenfield SAP implementation, organizations who are doing HANA for the first time. There are many features within this tool which can help you deploy your SAP system. First one is the instance sizing recommendation. So you have done your SAP sizing exercise, you have your SAP's requirement, then you can use this tool and it will predict you the best instance to use. For your SAP's requirement. If you're not for certain scenarios, if you're not sure about your sizing exercise, if you're not sure whether this is the right SAPs, but you know the CPU, vCPU, and the memory requirement, then enter those data. It will tell you what instance to use. Also, it supports a broad variety of best practices from both SAP and operating system perspective. For example, it automatically applies all the SAP required parameters to the SAP system. Same goes for OS based parameters, kernel based parameters, things like that. So now let's explore more about the SAP Launch Wizard in the next slide. Okay. So why SAP? Why AWS Launch Wizard? Launch Wizard takes away much of the heavy lifting for you in setting up your landscape on AWS. At the infrastructure layer, it sets up the right size compute and storage, security services, networking services, and monitoring. If you're deploying HANA, you don't have to worry how much I need to size for my HANA data, how much I need to size for my HANA log. It takes care of everything, right? At the operating system layer, it configures your SAP OS parameters, users, sets up the volumes, and even sets up high availability clustering if you ask it. And finally, at the application layer, Launch Wizard can install your SAP S for HANA or any other native system, set up your HANA database, and have your vanilla SAP system up and running, configured to take advantage of the underlying AWS services. As you can see, Launch Wizard for SAP can reduce your SAP system deployment time from days to minutes. You don't have to go through all the guides of HANA. You don't have to go through all the guides from an SAP application perspective. You don't have to worry about how to set up your clustering, SUSE clustering, or Red Hat, or any other third-party clustering that you might be using. Specifically, Launch Wizard at this point in time can configure only SUSE and Red Hat clustering. So you don't have to worry about all those things. It takes care of. And most of the times, what we have seen with customers is that although they have set up a high availability clustering, in case of a service disruption, the high availability failover doesn't work properly. So you don't have to worry about setting up, and all you need to do is provision the AWS resources, install SAP, install a HANA, set up HA clustering, and then just do one round of testing. The testing needs to be done because you need to make sure that it will work when there is a service disruption to the node or any other services, right? Finally, your SAP system is ready for use. Remember the architecture patterns that we had discussed earlier. AWS Launch Wizard supports all of them. Single instance deployment, distributed instance deployment, distributed instance with HANA scale-out deployment, high availability deployment across multiple AZs, and the timing depends on the time to deploy the resources, to install SAP, install HANA, to set up HANA cluster. It depends on what type of instances are provisioned, what type of architecture pattern you are going for. So the runtime will depend. But today we will run through a high availability setup, and we will see that the entire system, along with HANA clustering at the HANA level, clustering at the ASCS ERS level, HANA system replication, everything is done within less than 3 hours. We shall see that today. So this is our latest feature from AWS Launch Wizard perspective. When customers deploy SAP application with AWS Launch Wizard, it can save the cloud formation templates and the application configuration code in customers S3 buckets, right? So, yep. So you can use the AWS service catalog products along with the integration with third parties such as ServiceNow, Jira, or Terraform. So, or you can use the AWS CloudFormation templates and application configuration scripts saved in the S3 buckets for repeated deployment of your SAP applications. So, what are the benefits with this newest feature from Launch Wizard? First is choice. Use existing deployment tools like Service Catalog, ServiceNow, Jira, CloudFormation, and process of their choice for deploying SAP application. Second is versioning. Adapt new launch wizard features and capabilities at your own pace. The third is the simplification. This launch allows our customers to reduce the number of inputs that are needed to repeat deployments of your similar AWS SAP deployments. For example, when deploying multiple HANA systems of the same version in the same VPC, or and even in sometimes even in the same subnet, you can default these settings in the AWS Service Catalog and let the end user only interact with the other inputs, change the HANA state, change the HANA instance number, so on and so forth. So this is our latest feature from Launch Wizard, and it now gives customers the flexibility to integrate with some of the tools that they might be using today from an infrastructure provisioning perspective, not only SAP, right? So, so like I said earlier, AWS Launch Wizard can also configure Red Hat and SUSE slash clustering for high availability at the SAP application layer, as well as the HANA database layer. HA deployment setup will configure the cluster resources and build a highly available application that spans multiple AZs. So now this is what we are going to do today. We will launch the EC2 instance. We'll see how AWS Launch Wizard help you launch the EC2 instances, configure EC2 EBS, install the HANA database, take the backup of HANA database using AWS backend agent, enable HSR. So HANA system replication will also be enabled automatically, 100% automation. Enable clustering for HANA, enable clustering for ASCS ERS, configure the NQ replication, deploy the SAP application. So everything is taken care by AWS Launch Wizard for SAP. In the demo today, I have set up the system landscape as shown in the slide, very similar to what you would normally do. The only difference I would say that I have a Bastion host in a public subnet to access my SAP application. Apart from that, everything is exactly same to a typical HA clustering architecture, right? Multi-AZ clustering architecture. So let me do this. Let me go to my, yep. So first things first, right? So you need to download the SAP software. As you can see here in the documentation page of AWS Launch Wizard for SAP, you will see how to organize your SAP software, how to create the S3 buckets, and how to organize the paths for the different software components like SAP car, export, kernels, separate everything out. So this is one of the common mistakes that I have seen customers do while they are using AWS Launch Wizard for SAP. So make sure you follow this pattern. Make sure the structure is appropriate. and then put your software. And then depending on your depending on the application that you are going to deploy, whether it is S/4HANA or BW4HANA or a native system, everything is documented here. So make sure you follow this document, otherwise your deployment is going to fail, right? So now let's come to the Launch Wizard, right? Before I go to Launch Wizard, let me show you what I have, right? So let's go to the VPC. So I'm using the Canada Central region as a region for deployment, just because I don't have any other systems deployed here, so it will be easy for you to follow. So what I have done, I've created a VPC. I'm calling my system S23. That's the SID. You can come up with your own SID depending on your naming convention. So I have created a VPC here. And the IP cider block that I'm using is 10.0.0/16. So if you go, I use this utility cider.xyz. Yeah, you can use your own utility. So this utility will give me the usable IPs, right? The first usable IP, the last usable IP, how many IPs are included within the cider range, right? Why this is important? Because when you are going to use your overlay IP, it has to be outside your VPC cider range. So this utility kind of helps you to make sure that the overlay IP that you are using is not within the VPC cider range. So I use that. And then I have set up my subnets, right? Remember, if you remember, let's go back quickly. Yeah. So this is the architecture. So I have subnets for application and separate subnet for HANA database. So 1, 2, 3, 4 subnets, all private subnets, and 1 public subnet, right? So yeah. So this is what you see here. I'm using some kind of a naming convention. Always good to use one. You can come up with your own naming convention. So I'm using AZ1B, AZ1A, private subnet 1, private subnet 1, and then for the private subnet 2 within AZ1A, private subnet 2. So two would be used for the application layer, 2 for the database layer, and then we have the public subnet for wherein I have the Bastion host, and I'm going to use the Bastion host to access the. It's not always required to use a Bastion host, so in my setup I have used a Bastion host. So this is all I have in my in my setup. Also, I have a set of route tables. I'm using 2 route tables, one for my public subnet, that is for my Bastion host, and another route table for my private subnet, basically for all the SAP application. So let's see what the route table says. So, so the private subnet is going to talk to the internet. So AWS Launch Wizard needs a connection to the internet to download OS packages, so on and so forth. So so I have configured a NAT gateway. So my private subnet is going to talk to the NAT gateway, which will direct the traffic to the internet. And then I have my public subnet, wherein I'm going to the internet via my internet gateway, right? So this is the flow. And I have nothing else. So we are going to provision everything from scratch, right? So let's go to the AWS Launch Wizard. So let's go to the Launch Wizard. Here I clicked it. So I'm going to select SAP because SAP, I'm not going to deploy MS SQL or Active Directory now. My application is SAP, so I select SAP here. First, it's going to tell you that it's going to create IAM roles that are needed to access AWS services on your behalf. So to provision the resources, it needs IAM permissions. So that's why it's going to create those roles. And then first thing first, we need to give a deployment name, right? So I call it as 23 deployment Then, if you remember, I spoke about the latest feature from Launch Wizard, create AWS Service Catalog. So at the end of the deployment, it will create the service catalog for future repeated deployments. You can select or unselect depending on your choice. And then also you have a text box here which will say, do you want to roll back your resources if the deployment fails? For example, just hypothetical, right? If there is no connection to the internet, or if it is not able to download packages, then do you want to roll back all the deployed infrastructure, or you want to keep it as is? So this gives you a choice what you want to do. We usually suggest our customers to not to roll back. That way you can troubleshoot. You have your EC2 instances up and running. You can log into those and see why the deployment failed, at what step it failed, so on and so forth, right? So I'll select a S3 button, S3 bucket here for my service catalog, right? And always a great idea to use tags. AWS deployments are about creating tags. For example, let's say SAP SID is S23. This is a tag I'm using. You can use up to 10 tags depending on how. For example, you can say deployment type, production, so on and so forth, right? So you need to come up with a tagging strategy before you start deploying SAP systems on AWS. That will give you an organized, set of deployments. Now you're going to configure the configuration options. Here you can create your own configuration, or if you have already configured earlier, you can reorganize. You can reuse. So I'm gonna call this let's say S4 prod config. Let's see. Okay. So for example, this is a deployment, and it will ask you for the deployment environment. I'm going with production for now. Key pair, for every reason you need to have a key pair. I already created the key pair well in advance. Otherwise, you can use this hyperlink to create your key pair. Now remember, I told you I already created the VPC, so I'm going to select that VPC here. And here, since I'm going to do a HA deployment anyway, so I have to select two availability zones. I select 1A and 1B. Remember the private subnets that I already created: private subnet 1, private subnet 2 for 1A, similarly for 1B, 1, subnet 1, subnet 2. So we will deploy our SAP application components here and here, database here and here, right? So that's how it is. And then I need to select the verify connectivity. So it will make sure that selected private subnets have outbound internet connectivity, like I said earlier. Always another tip I can share here is, once you create your subnets, you can provision a small size instance for temporarily for like 10 minutes. You provision the instance in one of these subnets and see whether you can reach the internet. That way you don't have to run multiple launch wizard config deployments. So create a small instance in one of these subnets, make sure it is able to reach the internet, then decommit and then just shut it down. So that's the power of AWS. That way, when you are running your AWS launch wizard deployment, it will succeed, right? And now we are going to create new security groups. So one security group for your application servers, one security group for your database. And then here you are going to specify your organization IP side events, right? For example, this is a lab system. I don't care much. So I'm selecting, let's say, open up to the internet. That's not a good practice at all. I'm not suggesting, but since I don't want to disclose my IP CIDR range, I'm using opening it up. But use your organization CIDR range so that that's the appropriate way to do it. Okay, now then you select your time zone. For example, I'm selecting Eastern. You can enable encryption or disable encryption. For now, I'm going with do not enable. You can configure your DNS depending on what DNS you are using, and then specify the SAP sys group ID for SAP system IDs. Let's select 2301. Okay. And then while you are running this deploy or configuring or running this deployment, in case of errors, you don't have to sit in front of your screen to make sure that it is running perfectly, right? So you can configure SNS. What is SNS? Simple notification service. So basically it's a pub sub messaging system, if you're aware of the pub sub concept. So basically there's a topic, and then for each and every topic you can create multiple subscription. Let's see, I can show you this real fast. Okay. So what I have done, I've created a topic called Launch Wizard topic, and this topic has subscription. So if a deployment fails or if there is an error, it will send me a email in my email ID. I can create another subscription, use the same topic, and let's say I want to get notified via text. So I'll add the phone number here. So there are different ways you can use this feature. Very helpful when you are doing deployments which spans more than, let's say, 30 minutes. You don't want to continuously monitor the deployment. And then it will ask you, what do you want to deploy? Is it a SAP native system or just a HANA database, HANA standalone database? I'm going to deploy a SAP system, so I'm going to enter the SAP set. Here you can specify your system ID. You should have your own naming convention. So for this deployment, I have come up with this naming convention. SID is S23, ACS instance number is 10, ERS instance number is 20. The host name is S23 ACS for the ACS instance. For the ERS is S23 ERS. The virtual host name, I am adding just VH at the end to maintain some continuity in terms of the host names. And these are the IP overlay IP addresses that I'm going to use. So same goes for HANA database. Instance is 23, and the host name will be H23DB VH for the virtual host name. Okay, let's go ahead. You can select depending on the type of your installation, and you have to select an appropriate storage type. For now, I'm selecting GP2. If this is kind of the first system, you'll select to create a domain controller, transport domain controller. If you don't have, if you don't want to do this and want to do this manually, it's up to you. I'm going ahead and creating a transport domain controller for my SAP system. Now I come to my HANA system settings. H23 is the SID. 23 is my instance number. I'm selecting GP2 for both HANA data and HANA log, right? Okay. Now let's go back to my first couple of slides, right? So I talked about different architecture patterns. So why that was important is it's because now you need to specify what kind of deployment pattern you're going to use. So I'm going to use high availability deployment, right? So yesterday, Sunil and Ras spoke about different security configuration, and then Sunil showed you how to create a hardened AMI. This is where it comes into play. So if you are bringing your own AMI, you have to select this option and then select the AMI ID. Okay, or you are gonna use the AMIs available in AWS Marketplace. So for now, I'm going to do that. For high availability deployments, you have to select uh, slash for SAP, or rel for SAP, right? So I'm going to select one of the images from AWS Marketplace. Always remember, if you select this option of using emails from AWS Marketplace, you have to subscribe. So what you basically do is you go to your marketplace and you have to select the region and the instance type and hit subscribe. So you'd be paying this much amount annually. And then once you make this purchase, um, you are ready to go. You are ready to use this image. Basically, that's how you do the subscription for Slash for SAP and REL for SAP. Now for S23 ASCS, this is the host name. You can do both custom IP address as well as private IP address, auto assign IP address. So what it will do is, if you want to, from your CIDR range, remember from your CIDR range in your subnet, if you want to use a particular IP, you can enter it here, or you want to have Launch Wizard assign an automatic IP from the pool, you can use the auto assign IP address. Now comes the instance sizing. So there are a few methods that we are going to run through. First is based on infrastructure requirements. Remember, I told you, if you know the instance size and the instance memory, your launch wizard will calculate. See here, it's calculating. Okay, 4 vCPUs, 16 GB memory, and 5 extra dollars is the best option, SAP certified. You don't have to worry about whether the instance is SAP certified or not. You get to know it right here. And then the other option is, you already know what I need, then go for it. Search from this list and use the instance, right? So that's one way. Similarly, you will do it for your ERS instance, right? Red Hat, I'm selecting Red Hat, S4P, S23, ERS, right? Auto assign, instance number is 20. And okay, I know I need M5 large, so I'll go with M5 large straight away. So here it will tell you how much resources it's going to provision, how much it's going to cost you, everything. Everything is transparent here. And now comes the database, right? So for database, let's say I selected the AMI, I selected deploy database in separate subnet. Remember my architecture pattern diagram. So I'm going to select this. Here you can, whatever works for you based on your naming convention. I'm just going to keep it same. I'm not going to change anything here. So here you need to specify the overlay IP. See, it talks explicitly, overlay IP has to be outside of the VPC side range. So I'm going to use 10. Let's say 23.0.23. Okay, something like that. You can come up as long as it is outside of the CIDR range, you are good. So let's see. So my last usable IP is 10.0.255.254. So this is definitely hold on. Okay, sorry. This is definitely outside my CIDR range, so that's good. You have to give a tag for your pacemaker. I'm keeping it same. I'm not changing anything. Now, um, again, here you have also the option of going by your SAPs, right? So you have done your sizing exercise. You know, okay, I need 90,000 SAPs, for example, right? So it will tell you what instance to select and how much it's going to cost you. R516X is the recommended instance for your sizing exercise based SAPs requirement, and it's going to cost you this much. It is going to provision this much of storage, so on and so forth. So same goes for primary application server, additional application server that you want to configure. So let's do this real fast. So I'm good. I'm going with an additional application server. I call it S23 AAS, auto assign. Enable EC2 auto recovery. Remember I told you about auto recovery, wherein if a EC2 instance goes down for some reason, it will move to another hardware within a few minutes. So you want to enable this option so that if there is an underlying problem, you get back the system within a few minutes. So I want to enable that. This is my requirement. And then you have your pre-deployment configuration script. So pre-deployment and post-deployment, there are two options based on let's for example, let's say you want to use the AWS Marketplace image and you want to do some OS hardening. You want to run some scripts which does some OS hardening. You want to install some logging agents like Splunk. You want to install some security agents. You will do this in the pre-deployment configuration script. And in the post-deployment configuration script, you will do you can configure scripts that installs your backup software in case you don't want to use AWS backend agent. You want to configure ITSM operational agents, things like that, management, any kind of basically management in agents, backup agents, so on and so forth. So you can do this here. I'm not doing it. Let's go ahead. All right. So now it will ask you the SAP application software to install. I'm selecting S for HANA. You can select SAP Native on HANA or BW for HANA. I'm selecting 2020. Remember, I told you about how to organize your software. This is where it comes into play. So I'm going into my Launch Wizard S4HANA bucket. I have organized my install software as per the documentation, and I'm gonna use it now. Okay, let's SAP scar SWPM. Let's select SWPM. Let's select kernel. Okay, let's do this. Installation export. Boom, 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 boom. Installation export. Export. Yep. Okay. HANA database. Right here. HANA client. Right there. Okay. So I will use a password, my master password. Let me copy paste. Okay, pass installation number, let's say 01 S23 ACS VH. Virtual IP, remember 10.23.0.10 because I'm using a naming convention where the virtual IP is same as the instance number. VRS VH and 10.23.0.20. 20 is the instance number of VRS. Database virtual hostname DB VH. Yes, make a tag name S23 PM. Okay, now you can use, I'll talk about AWS backend in a couple of minutes from now. So you can use AWS Launch Wizard to install the AWS backend agent. So what will happen is once your system is configured, you are ready to take backups of the system. Basically, you don't have to do anything. So I want to use this feature. So I'll select a bucket for my backups. Okay, 1 second. And then yeah, you can use the KMS key provided by Amazon itself. Select the agent version, and then you have preferences here. If you want to backups the backups files directly to S3, it removes the requirement for EBS backup volumes. I'll talk about this little later. And select this option to ignore deployment failures and proceed with non-HA deployment if backend agent installation fails. So you can select if you want. And then finally, the IAM permissions. This is clearly mentioned here. What you need to do, you need to copy this IAM permissions and post it as in this role. Let me show you real quick. So this is your IAM role, and then you basically create inline policy wherein you say that, okay, whatever is specified in the instruction, you put it in the Amazon EC2 role for Launch Wizard. So make sure the policy is attached. It's all documented here. You just need to follow the instructions and you do next. You're ready for your deployment. So this is basically the review screen wherein you can review all your inputs, make changes if you need to, just like any other deployment. So today, in the interest of time, I'm not going to hit deploy and wait 3 hours. So I'm gonna show you a recorded version of this. Let me move my video screen here. Yep, right there. So basically, I'm continuing from the point I left over. So here is my inputs, and then I hit deploy. So you can see here, if you refresh the status, you can see all the different steps. And then if you move to the CloudFormation service itself, you can see there as well what's going on. And then within, say, I started my deployment at 10:03 a.m. It got finished at 12:41. So it took about 2 hours, 40 minutes to, install SAP, install DB, provision the infrastructure, HANA installation, HANA system replication, everything. Now let's verify, right? I spoke about my architecture pattern. Let's verify if the high availability architecture pattern is followed or not. So my primary database instance is on, this is in US West region. So you see US West 2A. Primary HANA is in 2A. Secondary HANA is on 2B. PaaS is on 2A. Additional application server is on 2B, right? That's what we're seeing. ASCS is on availability zone 2A. ERS is on availability zone 2B. So it deployed just like my architecture pattern, architecture diagram. So I'm logging into my SAP system right after my deployment using my Bastion host. Let's verify real quick. You see here, 2 application servers installed. System is S4 HANA, all verified. Okay, let's go ahead. Remember, we installed AWS backend agent. Before that, let's check the HANA system replication. HSR is configured, Pri HANA, Sec HANA. Sync, it's on replication status is active, all good. Now I'm going to take a backup. I don't have to do anything. Everything is configured using Launch Wizard. H23 is my tenant. I have to select the destination type to backend. And it's gonna back up directly to S3. Backup is running, as you can see here. Now let's go to S3 and select the S20 backup was my S3 bucket. So I'm moving under that. Let's see, it's 23. Backend folder. Yep, you have your tenant, you have your system DB. The backups are running, right? So this is kind of the end of the recorded demo. So today you could see, let me go ahead, close this. Let's go back to my presentation. Okay. So we deployed this architecture using AWS Launch Wizard, and now, okay, now let's talk about backend agent. I kind of showed you how to deploy using AWS Launch Wizard. Now I'm going to talk about it in little more detail. So what is AWS Backend Agent? It is AWS's purpose-built SAP HANA database connector to send and receive backups directly on Amazon S3. Like I said earlier, AWS Backend is SAP certified, natively integrates with management tools like HANA Cockpit, Studio, so on and so forth. No additional cost for the agent, is securely controlled using AWS IAM policies. You could see some of those. And it's easy to deploy via AWS System Manager, which I'm going to show in the next couple of minutes. Or you can deploy it using AWS Launch Wizard, which you already saw, right? So why is it? Why is it important, right? So using AWS backend agent, you can take faster backups, faster restores, meaning lower RTO. For large HANA databases, AWS backend agent is optimized to use EBS throughput and network bandwidth available to Amazon S3 from your EC2 compute itself. For example, we have seen customers on high throughput instances and storage, backup as much as 20 terabytes in less than 25 minutes. You can also use native SAP tools to schedule log backups to S3 regularly. I already told you about that. And so basically, the speed of the AWS backend agent also allows a lower recovery point objective, RPO. It's secure. Off-system backups directly to S3, so your backups are automatically stored in 3+ locations with durability of 11 nines. That's the durability of S3. You don't need an intermediary SD1 backup storage. You can directly back up to S3. It's simpler. And usually, AWS backup generally results in cheaper backup architecture, avoiding the need of transitory storage like SD1, which I kind of told you earlier. Now let's look at the typical HANA architecture, right? So typically, you'll have a HANA instance, and then you have HANA data, HANA log, just like the instance I installed today. So what you would do without a AWS backend agent is that you will back up the files to a SD1 volume temporarily, and then use some automation script to push it to S3. Now, it's a two-step, even two-step to backup, two-step to restore. So more time, more complexity. With the AWS backend agent, you are backing it up directly to S3, and it's a one-step restore as well when you are doing the restore. And then you can use S3 lifecycle policies to move from one S3 storage type to another. Like, for example, after a certain period of time, you can push it to S3 Glacier. That way, you can do a lot of cost savings. Now, let's see how to deploy AWS backend for SAP HANA. Let me maximize. So first step first. So you have to first verify that the SSM agent is installed on the instance where HANA is running. And you need to check the version of the SSM agent. Minimum version that is required is 2.3.274. In case it is lower than that, with newer installs, it's not going to happen. If you have older SAP systems, your SSM agent might be older. In that case, you need to upgrade it to a version higher or to the latest version. And then let's see what we need to do. So I verified the SSM agent. Now I'm going to S3. I'm going to create a S3 bucket. Yep. You can use any bucket name. I use my own naming conventions. Might look awkward for you, but this is what I'm using right now. And then you select the region you need to create the bucket. I'm selecting North Virginia here. Let's go ahead. You can enable versioning. I have disabled for now. You can create your own tags. Always a good idea to create tags. Now I'm creating the bucket. Remember, all AWS services start with 0 access permissions. So until we give some access, nothing is going to work. So first, right now, we need to give the system manager permissions to run and access SAP HANA instance messages, access to write backups to S3, read data in S3, so on and so forth. This access allows SSM to handle SAP HANA backup, restore capabilities, the whole gamut, right? So let's attach. So first we are selecting the HANA instance. That's the HANA node. This is the IAM role for this HANA instance. Let's click here. Let's go to the IAM role. First, we are going to attach policies for SSM. Search this Amazon SSM Managed Instance Core policy, and then attach the policy to your IAM role. This is done. Now we need to add an inline policy as well. So remember the S3 bucket that you created in the earlier step. So we are going to give permissions to that. This is a policy you need to use. You can use this as a reference if you want to. And then make sure the S3 bucket name is correct. So I'm going to change it to 4523. That's the bucket I created in the step earlier. And now let's go to S3. Okay, so that is the bucket name. Your policy is good. Again, doing a re-verification. Review the policy. Give a name. I call it HANA backend S3 policy. You can choose your own name. And then basically verify. Yep. Basically, you are now done with the IAM permissions. Now let's go to session manager, system manager. In system manager, there's a concept of SSM document. What is an SSM document? It's an automation run book wherein you can define your own scripts that you want to run, right? So basically, think of SSM document as a collection of scripts that you want to run. So we already have a SSM document that is used for installing backend. So this is what it is: AWS SAP install backend. So using this SSM document, you can deploy backend directly. I mean, it's very simple. All you need to specify is your bucket, is your system ID, region, the account ID, that is AWS account ID. If you're using encryption, the KMS key, so and the installation directory where you want to install backend. That's what I'm doing. The HANA database here is HDB. I'll specify the region, the account ID. Those are blurred for security reasons, but make sure you use the correct ones that is applicable for you. And then, yep, that's what I'm doing right now. I'm copying, making sure the bucket owner ID is correct. So on the right-hand side, you will see the account ID. So I'm basically making sure that I'm pasting the correct account ID. I'm done. Then you need to select the installation path. Once you've do that, ensure that no backup is in process. So, yep. Then you need to, where do you want to run this automation script, right? Where do you want to run this SSM document? You need to specify the instance. For me, it's the SAP HANA master instance. I select that, and basically I'm kind of done. Once I select, if I want to, where do I want to put my output? I can select an S3 bucket where it will store all the outputs. And then once you hit, so at this point in time, it is deploying. You need to monitor. And once the command is successful, basically it means so at this point in time, it means that it was able to install the backend agent using SSM, AWS System Manager, and as a SSM document. So this is the process to so that brings to the end of our presentation today. So at this point in time, you learned about how to use AWS Launch Wizard, how to use AWS backend, how you can automate, how to select an architecture pattern, how to select an instance. Basically, I hope you were able to follow the entire session today, and it gives you a good idea so that the next time you need to deploy a S/4HANA system on AWS, you know end to end, right? Starting from making the architecture design decisions, selecting the instance type, using AWS Launch Wizard, using AWS backend for SAP. You can design and deploy your S/4HANA system. Tomorrow, my colleague Rosal will talk about the migration process in detail, and once you migrate, how to optimize. So that brings to the end of my presentation today. I would be happy to answer any questions that you might have.